Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to look at the waiting line and queuing system at Marrybrown. Queuing theory helps us understand how customers move through a service system, how long they wait, and how efficient the servers are.
Hi everyone, my name is Viviriani binti Agus Sofyan and I'm working together with Patricia binti Nohami, Siti Khadijah Aini binti Muhammad Taib, and Nik Nohadira Nazwa binti Nik Muhammad Irwan. In this slide, I would like to introduce Marrybrown Sdn Bhd. Marrybrown is a popular food franchise business in Malaysia. The outlet that we choose for this assignment is located at number 65 Jalan Perdagangan 5, Pusat Perdagangan Raub 27600 Raub, Pahang. This outlet operates every day from 10 a.m. until 10 p.m. Customers can enjoy their meal through dine-in, delivery or pick-up services depending on their preference. This introduction gives a brief overview of the business before we move on to the next part of our assignment. In this slide, we show a video of our 1-hour observation at Marrybrown. This video was recorded to observe the customer flow and the queuing situation during a 1-hour period. During the observation, one of our group members manually recorded the number of customer arrivals within 1 hour. At the same time, we also recorded the number of customers served within the 1-hour period. This data was collected to help us analyze the queuing system more clearly.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Patricia Nohami and I will be talking about the characteristics for Marrybrown. First, we have the arrival characteristics, in which, first of all, the size of the calling population is infinite, which means anyone can come. Secondly, is the pattern of the arrival system. The pattern of the arrival system is completely random, especially during peak versus non-peak hours, which usually follows the Poisson distribution, which is the standard assumption, where lambda equals to 21 customers arrive per hour from our observation. Lastly, we have the behavior of the arrival exists, in which that we have concluded there is patience from a customer, where they wait patiently and there is no disturbance. Next, we're going to talk about the waiting line characteristics. First is the length of the line, where there is no restriction when it comes to the queue, in which it is unlimited and customers can keep forming lines whether physically or standing around the kiosk. And secondly is the queue discipline, which is first in and first out, where customers are served in the order that they arrive. So when they arrive firstly, they will go out the same way. Now let's talk about the serving facility characteristics, which we have in two parts. The first part is the configuration of the system in Marrybrown. First of all, let's talk about the number of channels. It is actually a multi-channel system. There's 2 self-serving kiosks and 1 offline ordering counter, so the S is equals to 3. And next is the number of phases, where we have a multi-phase system. There are 2 phases. The first phase is the ordering phase, and the second phase is the serving phase. Thirdly, we have the number of the waiting lines. So there is multiple lines at phase 1, which is the ordering phase. There are separate queue for the kiosk and the cashier itself. And then for the second phase, which is the serving phase, there's a single line, which is a one waiting area for the food. For the second part, we have the pattern of distribution, where we assume that the service time follows the exponential distribution, where mu equals to 20 customers served per hour for Marrybrown.
Hello everyone, my name is Khadijah Aini binti Muhammad Taib. Now I will explain the queuing system analysis based on the data using the multi-channel queuing model. First, let me explain the data information. The arrival rate denoted by lambda is the number of customers arriving per hour. So, lambda equal to 21 customers per hour. The service rate denoted by mu is the number of customers that can be served in 1 hour. So, mu equal to 20 customers per hour. The number of servers available is S equal to 3. Next, we calculate the server utilization factor represented by rho. By using the formula, we can get 0.35. This means the system is operating at 35% capacity, which indicates the system is stable and not congested. Now we calculate PO, which is the probability that there is no customer in the system. Using the multi-channel formula and substituting the value, we can get 0.3451. This means there is about 34.51% probability that the system is empty. Next, we calculate LQ, which is the average number of customers waiting in the queue. By using the formula, we can get LQ equal to 0.0552 customer. This shows that very few customers are waiting in line, indicating efficient service. After that, we calculate L, which is the average number of customers in the entire system, including those being served. By using the formula, we can get L equal to 1.152 customers. So, on the average, there is about one customer in the system at any given time. Next, we calculate W, which is the average time a customer spends in the system. By using the formula, which is W equal to L over lambda, we can get 0.0526 hours. This is approximately 3.16 minutes spent in the system. And finally, we calculate WQ, which is the average waiting time in the queue. By using the formula, which is WQ equal to LQ over lambda, we can get 0.0026 hours. This is approximately 0.16 minutes or about 10 seconds of waiting time. After we use QM software, we can get same result as the manual calculation, which is average survey utilization is 0.35, average number in the queue is 0.06, average number in the system is 1.111, average time in the queue is 0.026, and average time in the system is 0.05.
Here is the conclusion of our Marrybrown QA system project. First, the number of servers provided is adequate. Marrybrown has 2 tap order machines and 1 cashier, so customer can place orders smoothly without long delays. The servers are lightly utilized, with a utilization of only 0.35. Secondly, customers are happy with the waiting time. Based on our observation and results, the average waiting time in the queue is very short, about 16 seconds. So, customers do not need to wait long. From this project, we learn from the number of servers affects waiting time and customer satisfaction. We also learn how to use a real observation data and QM for Windows to analyze a real-life queuing system.
That's all from us. Thank you.